In this video, we're going to use synthetic division to divide. In the last video, we used what's called long division, which has a lot of steps involved. And so synthetic division is a different algorithm that simplifies the process. One of the things that's important to note is that synthetic division only works if what you're dividing by is linear, meaning that x is raised only to the first power. If we have something raised to the second or the third power that we're trying to divide by, we have to use long division. All right, so the idea with synthetic division is to figure out what the zero is. So if x plus 1 were equal to 0, meaning it's one of our x-intercepts, that would be that x is -1. So we're going to use -1 to be what is being on the outside. And notice that our division symbol is sort of upside down. Next, what we're going to do is we're going to take the coefficients of our polynomial that we're dividing into. When we were looking at long division, we had everything lined up. All of the things that had x cubed were in the same column. Everything with x squared was in the same column. And so what we're doing is just getting rid of the variables and just using the numbers in the correct positions. So I'm going to put a 6, a -10, a -7, and a -15. Again, I'm just taking all of the coefficients of the polynomial that I started with. All right, then we draw a line here. And for the first step, you bring the first number down, which is a 6. Then you're going to multiply these two together and put that answer here. Multiply, similar to how we did in long division. So that'll give me a -6. And the difference here is that in long division, you subtract. In synthetic division, you add. So this will give me a -16. Then I repeat the process of multiplying this by this and writing it here. So -1 times -16 is +16. And then I add down, so that would give me 9. And then I multiply this by this, which is -9. And then I add and I get -24. All right, how does this help us? Well, this part, this last part that's sitting here, this is our remainder. And what's sitting over here is a polynomial that's 1 degree less. We started with something that was to the third power, so our answer here is going to be something to the second power. So writing our original polynomial was 6x cubed minus 10x squared minus 7x minus 15. This is going to be x plus 1, this is what we divided by, times, and now I'm taking this answer, 6x squared minus 16x plus 9. Each of the numbers that are sitting there are the coefficients of this new polynomial, starting with the first term going down 1 degree from the original. And then we have our remainder there, which was a -24. Our long-term goal is to try to find things that the remainder is 0, because that means that the binomial would divide evenly. Let's do another example. To start synthetic division, we think about what the 0 would be if x plus 4 were a factor. If x plus 4 were a, 7. If x plus 7 were a factor, that means that the 0 would be x equals -7. So -7 is what I'll put on the outside of the symbol here. And then I'm going to take the coefficients that are sitting there and I'm going to write them. Now, notice that this is starting with something raised to the 4th power. And so I'm going to put that in the first position. The coefficient there is a 3. The next coefficient is an 18. But notice that we're missing a term here. We don't have anything that is raised to the 2nd power. So I have to put a 0 as a placeholder there. So because I need to have all of the terms represented. So I've got a 0 for the x squared, then a -3, and then a +40. Okay, so again, this is my x cubed column. This is my x squared column. This is my x column. to the first power. Oh, wait. X to the fourth. Sorry. This is x to the fourth, x cubed, x squared, x, and then this is the constant or just a number. Okay. So we bring the first number down, and then we multiply these two together. Negative 21 goes here, and then we add down. Negative 21 plus 18 would give me a negative 3. Then we multiply again, and that'll give me a plus 21. I add down, multiply negative 7 by 21. Let's see. 7 times 21. Negative 147. I add, and then multiply again. Let's see, 150 times 7. This is going to be a positive 1050. And when I add down, I'm getting 1090 as my remainder. This is the remainder. And each of these items now has shifted over. So now when we write our answer, this is going to be the x cubed column. This is going to be the x squared column, x to the first power, and this will be the number. So looking at our original was 3x to the fourth plus 18x cubed minus 3x plus 40. And that's going to be equal to x plus 7 is what we divided by. Our answer is 3x cubed minus 3x squared plus 21x minus 150. And then we need to add on our remainder, which is 1090. All right. I have one more example where the 0 ends up being a fraction. So the factor that we're looking at is 3x minus 1. And when we solve this to figure out what the 0 is, we're getting 1/3. So we're going to do the same process of synthetic division, but we're going to have a fraction here on the outside to start. This is also one that we're missing the x squared term, so we've got to add a placeholder for x squared. So we'll have 9, 0, negative 1, and 2. All right. Bring the first number down and then multiply. 1/3 times 9 is 3. We add down. 3 times 1/3 is 1. When we add down, we'll get 0. And then 1/3 times 0 is 0. So our remainder here is 2. So 9x cubed minus x plus 2 is equal to 3x minus 1 times 9x squared plus 3x, and then plus 2 for our remainder. Again, we're going to use both long and synthetic division in the next section to factor polynomials completely, so we can use that for graphing.